as I welcome to the stage, Matheus.
Wow, that's great. Thanks. Yeah, great to see you there. Yeah, great to be here in London to talk about speed at scale. And yeah, let's try to do this in 20 minutes. So it's going to be a live version of the song. This is me, as I said, I'm a software engineer at this company called Medallia. I am to be in web performance. I'm part of the React Summit NYC community. And you can find me pretty much anywhere as Body Combinator executed. Before we start, I also wanted to know a little bit about you. So just checking, everyone works with frontend, okay, and with Preact. Okay. So there's this post called by 1915 that I actually like a lot. It's called Silent Engineers. And this post is part of the motivation why I want to share what I have to share today. And it goes as, there's the part that says, why browser developer use? I sometimes get the feeling that every developer out there is working for fun. Is there always posts from those people doing some hard stuff? Or you might think that PHP is never used nowadays because it gets never mentioned. And when it is mentioned, everyone is getting it in the comments. And he goes on, well, let's be straight. That's like 1% of all the developers out there. The rest of them are just learning and coding with their language of choice and being happy about it. Be it Fortran, COBOL, or PHP, etc. So, what I have to tell, what I want to talk about today is the realities of the industry when you don't get to work. For example, with the state-of-the-art tech and with the most modern things. So this talk is not about what's latest in React 19 or in Svelte 5 and etc. It's not about the most modern rendering patterns and ways to address integration and etc. What I'm here to share today is about modernizing your stack in the legacy code base. Also applying some well-known techniques like code splitting and experimenting with other stuff like Preact, and how to do that while targeting a wide variety of problems. So that you know, this is the reality of my industry. This is the kind of system I work in. A service platform. Surveys are one of the main signals in terms of customer experience for my company now. So this is the kind of a page we'll be talking about. So the first part of addressing performance in this legacy React code base, and I'm talking about a code base that goes like about a decade of existence in React, is modernizing the legacies. And this is kind of where we were. So React 15, Webpack V1, and Node 10. And this snapshot was not taken that many years ago. So you might be wondering, what's the correlation with that and performance? The first thing is that actually, sometimes when going from one major to another in React, there are some performance improvements, for example, in the bottom size. So when React went from 15 to 16, they got a 33% reduction in the bottom size, including React and React now. So that's something we wanted to do amongst other stuff. But at the same time, we had a couple of challenges. For example, this code base doesn't have TypeScript, like at least not entirely. So we were using a lot of prop types. So we needed to ignore that, but prop types changed because in React 15 they were part of the React package, and in 16 they are a whole different package. So we needed a strategy to do that, so there was not simply finding and replacing the occurrences because we had a wide variety of occurrences. So for this, we used a tool by Facebook called JS Code Shift, and who here knows JS Code Shift, by the way? We have used it. Okay, cool. So if you're not familiar, JS Code Shift is a tool that runs a transformation script over one or more JS or TS files. And if you expand on the definition we have on the website, it says, it reads all the files and provides data at runtime and analyzes and compiles the source into the AST as part of the transformation. It then looks for matches specified in the transformation script, deletes them or replaces them with the required content, and then regenerates your file from the new version of the AST. And the thing about it is that it plays really well with this thing called React Code Mod. So we at CodeMod, and CodeMod in general, are a collection of available scripts that you can plug in your JS Coaches pipeline to run transformations. And specifically, it played really well with the React prototypes when we needed. But they have like thousands and thousands of available mods. But then we had a problem because we were talking about thousands of customers that run our service for millions and millions of people. So we could not simply just roll it out, and we needed customers to first buy into this kind of performance improvements. So we needed to hide it behind a safe mechanism like a feature flag. So that's when our local generation started to get more and more interested. Because we had to support in parallel different versions of our developer dependencies. So Node.js, 18, Webpack V1, and V5, Babel, V something in newer version. Different version of our application dependencies, like different versions of Preact and other libraries. And also different strategies, like different configuration files and different things for all of the bundling and distributing data. So it's very good to visualize. So we had this one repo. And you can think as the core of the application where the whole UI and business logic and etc. was. And we went from this to this, where legacy was the default model that served if you don't have
How are we doing?
and that's where the active development was.
You're alive. Okay, that's good. That's good. That's good.
Where is streaming?
And all of that.
Yeah. Okay, we are.
Actually pushed
Okay, good.
because we wanted to have a version of the app, but we didn't want
It's
to
not
have
live.
two copies of the same.
Yeah,
code,
it is
right?
on stream.
And
Live.
this is the code that was built
comes it
in
not?
legacy. So this application was bought with 15 Webpack clients as well. Then we had this next wrapper, but I'm not talking about Next.js, this is the next iteration of something. And in this next wrapper, it was hidden behind a feature flag, and it included all the modern, as we more modern than the previous one, dependencies. And it was mostly composed of build transformers and automation scripts and Webpack config and all that. And it included some parts of the code that we didn't get to code generate with JS Code Shift because we didn't have the time to, or because they were so hard to deal with step analysis. And then we had the final model itself that was the build generate at build time. And that included, for example, all React components, utilities, business logic in general, and whatnot. But this code was never pushed to our repo, so we were also generating an R file that had more than 1,000 lines to not push this newer version, just the old one. So it kind of looked like this, and it plays really well with this tool called AST Explorer. So when you're building your custom code mods, you can also navigate through that. And the way we abstracted this was with transformer groups. So basically, with each transformer, we have a link to describe what it was doing. It would have pattern files that we were matching with lobby. So code mods are also really useful here because the code mod also has a bunch of code mods for React and some migrations. And if you check this company called Preact, they actually have a bunch of use cases, interesting use cases of migration. Large migrations using static analysis, companies like Polyfilling and Matheus. So super interesting. Also, outside of the React ecosystem, Nuxt also has some open source code mods for the Nuxt community and PM as well. And there's even a code mod studio by this company that you can use. But at the time I was doing all these things, I didn't know about this. Another thing we did was code splitting. So code splitting is quite popular in the React ecosystem using React Lazy and React Suspense. In our case, code splitting was very helpful to prevent our survey teams from downloading all the possible types of questions because we only wanted to download the questions we were actually answering. And as a final reason, yes, in the survey, you would only download the things that they are using. This is pretty good because then you're preventing unnecessary problems for being shipped. But just like any other performance optimization, you might have negative side effects. And in our case, our side effect with code splitting was we as a platform, we allow people to write custom JavaScript using CSS to make it integrate with our APIs or integrate with open source stuff or pretty much anything you want to do. And this is side-by-side React build. Just like with code splitting, we also had a couple of branches. And in this case, we had this interesting behavior where the questions of the survey started showing in a different order than they were supposed to. And I actually found a bunch of open issues on GitHub and Preact that was about elements of rendering in an order that I don't expect them to. But all of the issues, all of the described scenarios didn't really have to do with what we were doing. So for a lot of trial and error, we correlated that with our code splitting with Preact lazy and Preact suspense. So what we did was we started using loadable components. That's pretty much how we did code splitting before suspense and lazy. So with loadable components only added about 2 kilobytes to our own footprint. So the trade-off was worth to have both Preact and code splitting. And we did a lot of regression testing, and we did a lot of QA, etc. And no regressions were found. Another thing is jQuery. Yes, in 25. So you would be surprised that actually jQuery is still used by a lot of the web out there. And even though we were not exactly using jQuery in our code, a couple of years ago we decided to allow people to use it out of the box. Imagine like CodeBase, you can just use some libraries that are really inserted. And people started using jQuery to write their custom code and their fancy carousels and plugins and stuff like that. But jQuery, depending on the version you're using, it has some open vulnerabilities, but not only that, it also has performance fault because you're loading another extra few kilobytes, and also you're running some specific expensive non-manipulation. So basically, we wanted to remove jQuery at least for clients that were not using it. That would be a nice first step. So for that, we also use static analysis. So we did a very complex pipeline that would go through the customizations provided by our clients, their JS code, and that would pipe this data through Babel with the AST and reverse utilities of Babel to basically find the occurrences of jQuery and also understand those occurrences of jQuery. Which methods are they using? How are they using? Are they creating custom plugins and so on? And with this kind of thing, we were able to do this kind of report. So these are our clients using jQuery. These are these APIs, and then if you wanted to zoom in a specific line, you can see that they're using and whatnot. Another thing we did that is also super interesting are proxies, because we wanted to detect things in runtime. So with proxies to detect jQuery in runtime, so we wrote a bunch of utilities that would patch jQuery to report to us in runtime whenever a jQuery function was called and which parameters were used and which function was called, so that we could understand if we removed it, for example, for someone that actually was using it or not. So you can then send this data over to some argument or something. And then last but not least, with static analysis, we also did interesting proof of concepts on compiling old jQuery code to modern code using, for example, going from Ajax to Fetch API and so on. One of the last things is, for targeting different browsers, we had to think of polyfilling. I won't dive into too much of polyfilling, but we could definitely talk about it in the rankings. But basically, we had a very wide variety of browsers using our app, including Explorer 10, for example, and Nokia browsers, Blackberries, and whatnot. So we needed to think about polyfilling. And the way we did polyfilling was we didn't go with things like polyfill.io or anything like that. We went with the module/module attributes you can do your script tags to basically string with browsers that didn't support ES5 or ES6 versus the ones that supported. And we used runtime detection to detect that. So basically, we would see if that browser, if the script tag in that browser would support that or not, and then we would load the right module and monitor the one including all freeze. And at the end of the day, I was happy that we didn't use polyfill.io because it was then acquired by a company that had a supply chain effect of like 100,000 sites. So some reduce, we had a lot of very requests. These are just two of them. But at the end of the day, our test suites were all still passing. Our modern bundle, so the ones that were shipped, the modern browsers went from 280 to 175 kilobytes, 176. And for the legacy browsers, the one that we still needed to ship all of those, we went from 280 to 223. And this split was basically on top of ES module support or not. So on the other side, we had pretty much Internet Explorer. And at the time, that only meant 0.2% of our use space. So we were being fine because most of the people got the modern version at 176. A lot of format files also improved. So basically, FCP, speed index, FCP, TPI, and all of that got a couple of seconds faster. Oops. Other timings also improved, measured with web page stats, so visual completeness and all that you can see with the feature flag on versus the feature flag off. The visual progress as well, feature flag on versus off, it all improved. Let's 2 minutes, a couple of closing thoughts. A couple of closing thoughts, so let me demonstrate this one. Regarding polyfilling, since I didn't get to talk a lot about it, yes, many of your users, you have to ship polyfills for all the browsers your users might want to use, but it's a bad idea to ship it for all of them. Do not take fast CPUs, GPUs, and memory RAM for granted, depending on who's your use base, because it might differ a lot, the quality of connection, and even the speed of the same connection type is rather low. And there's no silver bullet. Do identify what's important for your users and try with different performance techniques and see the ones that work for you. If you're more interested in this topic, there's a larger version of these slides. And this is, you can find me everywhere as my computer. Thank you for having me.